For thousands of years, humans have watched a solitary red dot drift across the night sky. Our ancestors projected their myths and fears onto its crimson glow, struggling to understand what that distant light represented. Because of its blood-red color, the Romans named the planet Mars after their god of war. For centuries, it remained a symbol of conflict and mystery. Today, that mystery has been replaced by an audacious physical goal. We are currently preparing to transform this frozen desert into humanity's second home. This side-by-side comparison shows one of the planet's most inviting characteristics. A Martian day, known as a sol, lasts 24 hours, 39 minutes, and 35 seconds. Its rotational cycle is nearly identical to our own. A person standing on the surface would witness familiar sunrises and watch the sun set over a solid, rocky horizon that looks strikingly similar to the high deserts of Earth. But these similarities are only surface level. Beyond the familiar day-night cycle, the Martian environment operates under a set of strict physical rules that are entirely hostile to human biology. To determine if settlement is even possible, we have to look past the scenery and examine the environmental extremes that define this world. This chart shows the primary physical constraint of the planet. Mars has only 38% of Earth's gravity. As the scale illustrates, a person weighing 70 kilograms on Earth would feel as if they weighed only 27 kilograms on the Martian surface. Over billions of years, this low gravity allowed the planet's geology to grow to massive proportions. Without the heavy pull of Earth's gravity to limit their height, volcanic structures and canyons reached scales that are impossible on our homeworld. This massive central caldera belongs to Olympus Mons, the largest volcano ever discovered in the solar system. At 22 kilometers high, it stands 3 times taller than Mount Everest. Pulling back to see the full base, its footprint would cover much of France. This same geological freedom created Valles Marineris, an expansive system of rocky canyons that dwarfs any similar formation on Earth. These canyons stretch over 4,000 kilometers across the planet. To find an equivalent distance on Earth, you would have to travel from New York all the way to Los Angeles. These features demonstrate that the Martian landscape was shaped by ancient, large-scale tectonic forces. Any human attempt to traverse this terrain means confronting geography that exists on a scale we've never navigated before. The planet's famous color is the result of a specific chemical process. The surface is covered in iron-rich rocks that have oxidized over billions of years, effectively coating the entire world in a layer of rust. Windstorms lift this rusty dust into the sky, creating massive clouds that engulf the globe, dense enough to block out the sun for months. These storms have already claimed our machinery. In 2018, a global dust event choked the solar panels of NASA's Opportunity rover, draining its batteries and permanently ending its 15-year mission. Temperatures are equally unforgiving. While a summer afternoon at the equator can reach a pleasant 20 degrees Celsius, the thin atmosphere cannot hold that heat. After sunset, the temperature immediately plunges below minus 70 degrees. Near the poles, winter temperatures reach minus 125 degrees Celsius. This freezes carbon dioxide directly out of the atmosphere, creating the swirling white layers of dry ice seen here on the polar caps. These physics create a world of lethal contrasts. On Mars, the lack of atmospheric insulation means the heat of the day vanishes the moment the sun disappears. Despite its current state, the landscape contains a major historical contradiction. Satellite imagery has identified dried-up riverbeds, carved valleys, and ancient lake basins scattered across the surface. This evidence has led to a scientific consensus. Mars once possessed abundant liquid water. Because water is the primary requirement for life as we know it, researchers believe the planet may have once been habitable. We are currently searching for proof of that habitability. Robotic rovers are following these tire tracks across ancient lake sediments, collecting samples to search for signs of fossilized microbial life. Discovering even a single fossilized microbe would confirm that biology can emerge on more than one world. It would provide the first physical proof that life is a repeat event in our solar system. For now, the planet remains a silent graveyard. It stands as a reminder that even water-rich, habitable worlds can lose their atmospheres and transform into barren deserts. Despite the freezing temperatures and the lack of surface water, Mars is the primary candidate for our first off-world colony. This chart highlights the most immediate obstacle to that colony. The Martian atmosphere is over 95% carbon dioxide, making the air unbreathable for any human settler. This thin atmosphere also fails to block space radiation, requiring every habitat to have heavy, specialized shielding. Furthermore, because nothing can grow in the toxic soil, all food must be produced inside sealed, pressurized biodomes. To survive these conditions, astronauts will likely spend most of their lives in underground facilities, using the Martian crust as a shield against radiation. If these technical challenges are solved, it will lead to an unprecedented evolutionary milestone, the birth of the first human child on another planet. Overcoming the environment on Mars represents a definitive threshold in our history. It is the moment we determine if humanity successfully becomes a multi-planetary species, or if we remain bound to a single world.
Subscribe my channel for more informative video like this and press the bell icon for latest notifications.